Hey guys, it's Chavez. I hope that you're having a pretty good start to your summer, your official summer. And I guess let's do a little bit of math and go right into the first notes of your summer session. So here's page two. I hope you read page one. I put a lot of thought into what I typed there. And so let's start. So this is supposed to be like you guys asking me questions, right? So Chavez, what is an imaginary number? So first and foremost, I want to start by saying that math, for the most part, the majority of math was discovered because math has always been around, right? It's the language of the universe. But imaginary numbers were invented, and they're very useful, like in AC analysis, AC circuits, and like damping issues. When it comes to engineering and stuff. But for now, let's just understand what an imaginary number is. So, what's an imaginary number? An imaginary number is the square root of negative 1. You know that the square root of 1 is 1, but if I have a negative in there, if you try to do this on the calculator, it's probably going to say error unless you already have it in imaginary mode. So the square root of negative 1 is described as I. So let me see if I can take out the calculator and see if I can show you guys that. So here's my calculator and press menu. Okay, add calculator. I don't remember if I have the imaginary mode in here. I guess we're going to find out right now. So I'm going to put square root negative 1 and I'm going to push enter. Oh, yeah, that's a good way to start the lesson here, guys. Square root of negative 1. Come on, buddy. Negative 1. Enter. And you can see here it says none row result. So you have to put it in rectangular or polar mode. So to do that, it's really quick. Go to the home screen. Number 5, settings. And then number 2, document settings. And then where it says real or complex. Real or complex. Put rectangular and put make default so it could go to all your documents. And so I'm going to go to number 2, my documents. It was an unsaved document, so there I am. So if I do square root of negative 1 again, it's going to say I. So don't confuse that I with the I down here in the keypad. To find that I, you're going to have to push that pi, and there it is. It's that I right there. Okay, so now that we got that out of the way, let's go ahead and talk about what I squared is. So I squared is nothing more than I times I. And we already know that I is the square root of negative 1. So square root of negative 1 times square root of negative 1. Now, hopefully you remember from your laws of exponents, so square root of happy face times square root of happy face. Notice that I have happy faces. That's just going to be happy face. If you don't like that, I guess you can always do like a triangle if you don't like happy faces. Square root of triangle times square root of triangle is just triangle. So from that knowledge there, square root of negative 1 times square root of negative 1 is just going to be negative 1. All right, so what about I cubed? Well, I cubed is just going to be I squared times I. And we already know what I squared is. I squared is negative 1. So negative 1 times I, and you just get negative I. And there it is. So I cubed is negative I. And what's I to the fourth? Well, I to the fourth is I squared times I squared. And, well, I squared was negative 1. So negative 1 times negative 1 is just 1. And then when you get to I fifth, well, that's just I to the fourth times I from your laws of exponents. And I to the fourth was 1. So 1 times I is just I. And then you start all over again, guys. So it just keeps repeating with the same thing. So this is just that. And then it just keeps going over and over. And that's it. That's what an imaginary number is. It's just the square root of negative 1. It's imaginary. So what's a complex number? A complex number is a real plus an imaginary. So the real part is this part. So real, and it can be a radical as well. It can be any real number. And then the imaginary part is, well, technically it's the I that makes it imaginary, but the B is a number, quote unquote. But this whole paired, that number is paired with that I, makes this an imaginary. So there it is. That's what a complex number is. And it doesn't have to be plus. It could be minus. Or I guess B could be negative. And there it is. So if you were to Google, you'll probably see A plus BI as the popular complex number there. All right. So let's get right into it, guys. Now that we have an idea what an imaginary number is, now we can go ahead and get right into it and start with this. So it says, how do we have to track complex numbers? Well, it's simple, guys. We just combine like terms. So that's all you're doing. This is a plus, so I can just rewrite this as 1 minus 6i plus 12 plus I. I don't have to distribute anything. And then just combine like terms. So that 1 and that 12 are the same. So 1 plus 12 is 13. And then that negative 6i plus I, that's going to be a minus 5i. And that's it. You're done. So yeah. So you don't necessarily need a calculator for this, guys. I guess you can use the calculator if you want to, but try not to because they're not that difficult. All right, so here we go again. So we have a minus there, so this time I am going to distribute. So I have negative 5 minus 6i minus 10 minus I. And then we just combine like terms. So here's a real, that's a real, here's an imaginary, that's an imaginary. So negative 5 minus 10, that's a negative 15. See? And then negative 6i minus I, that's a negative 7. Make sure to put the I on there. And you're done. That's it. That's your answer. And it really was that simple, guys. So I guess let me go ahead and add these, and that's where you get that 15, and the double underline goes to those two. All right, let's go to the next one. What about multiplying complex numbers? It's the same, guys. You're just going to FOIL. So here we go. And you don't need a calculator for this, guys. Try not to use a calculator for this. I'll show you how to type it into the calculator just to verify. So here we go. Negative 11 times negative 3. So all these numbers are numbers that we should be able to multiply. That's going to be a positive 33. Oh, sorry, guys. Sensitivity here. Positive 33. So negative times a negative is a positive. So now I have negative 11 times a negative 9i. So that's going to be a positive, so plus. And that's going to be a 99i. Negative times a negative is a positive. And now I'm going to go negative 5i times a negative 3. And that's going to be a positive 15i. And then negative 5i times a negative 9i, that's going to be a positive, what's 9 times 5? 45. So it's going to be 45i squared. So there it is. So now remember what we've talked about up here, that I squared was equivalent. So it's right here in green, guys. I squared is equivalent to negative 1. So we come back down, and I'm going to write, where are you? Here we go. So 33 plus, if you want to go ahead and combine these two, you guys can go ahead and do that, guys. Combine like terms. 99 plus 15. Well, 100 plus 15 was 115, so that must be 114, right? 114i. And then plus 45 times negative 1. And I'm not insulting your intelligence, guys. I know some of you guys can do that in your head. Can already just put that plus to a minus. I just want to show all the steps here. So 33 plus 114i minus 45. So now we're going to add these two guys. So the difference between 33 and 45, let's see. 33 or 43, 43, 44, 45. So it looks like it's 12. The 45 is larger because of the negative, so negative 12 plus 114i. Now I make mistakes all the time, guys. So let me check that I did not make a mistake. 33, 43, 44, 45. No, everything looks legit. So let's check. So I'm going to check this with my calculator. Try to do them by hand, guys, because we're just getting, ready for this. So here's how you do it in the calculator, guys. I'm going to take out the calculator here, and I already have it in rectangular mode because I did that earlier. You guys saw when I did that, so I'm going to write negative 11 plus, minus 5i, so minus 5, little caret there, little pi there. Come on, buddy. I. And then open another parenthesis, and I'm going to write negative 3 minus 9i. Negative 3 minus 9i. I push enter, and there it is, negative 12 plus 114i. Now, when you go to engineering, guys, they don't use the letter I, and that's because I in engineering stands for current, so they use the letter J in engineering. So I probably should have written that somewhere up here. I'm going to write in engineering, comma, they use the letter, quote unquote, J for imaginary. So don't freak out when you see engineering books and it says 5 plus 3J. That's just what they use in engineering because the letter I is reserved for current. All right, here we go. Let's go to the next one. So this is you guys. What if my complex number is raised to a certain power? Well, we just expanded then. So 1 plus 2y raised to the 4th. You're always going to do it this way, guys, because of the pattern that imaginary numbers have. I know that you can probably use Pascal's triangle, but don't. Not in this situation because of what's going to be happening. So you'll see what I'm talking about. 1 plus 2y, 1 plus 2y, 1 plus 2y. So what I'm going to do first, I'm going to FOIL these two, and I'm going to FOIL these two. Now, they're both the same, so it should be pretty easy to multiply and FOIL these out. 1 times 1 is 1, so here we go, 1, plus 1 times 2 is 2, but I'm going to have 2 of those because, look, then you're going to have 2 times 1 again. So it's going to be 4i, and then I'm going to do, well, I guess I don't want to take a shortcut yet, so I'm going to put plus in. I was going to go ahead and... Anyways, 2y times 2i is 4i squared. Now, remember what we said, that I squared was equivalent to negative 1. So what you really have is 1... Well, I guess I'll do this here on the side. What you really have is 1 plus 4i minus 4, because of the I squared is negative 1. And when you do that, 1 minus 4 is negative 3. So negative 3 plus 4i. So here's what you have. You have, and again, you're going to have the same thing over here, 1 plus 4i plus 4i squared from these two. And then the 1 plus 4i plus 4i squared reduces to negative 3 plus 4i, and then negative 3 plus 4i. And we're doing the same thing again, guys, and it's really that simple. So let's see if we can do it again. Negative 3 times negative 3 is a positive 9. Negative 3 times a positive 4 is a negative, what's that, 12? But you're going to have 2 of those, so negative 24i. And then 4i times 4i is a positive 16i squared. Again, 16i squared, that's going to turn into a negative 16. So 9 minus 24i minus 16. And then we're going to combine those two. So let's see, the difference between 9 and 16 is, what's that, 7? And the 16 is larger, so negative 7 minus 24i. And there it is, guys. And we're going to check it with our little calculator here. So what is it? 1 plus 2i to the 4th power. So I come back in here and I go 1 plus 2, and then, come on, buddy, I. And I'm going to raise this dude to the 4th power. So raise to the 4th. And I push enter. And there it is, negative 7 minus 24i. That what we got? Yep, that's what we got. And that's how you do it, guys. And so here's another one. And I read this one to the 3rd power because, you know, we need to have an odd one as well, right? So you're going to do the same thing, guys. It's really going to be the same. You're going to write 2 plus 3i. Excuse me. I want to write it a little better. 2 plus 3i, and then 2 plus 3i, and then 2 plus 3i. That's what that 3rd power means. It means that we take 2 plus 3i and you multiply it by itself 3 times. So a lot of students, the mistake that they do is they go 2 to the 3rd power and then 3i to the 3rd power. Don't do that. You got to distribute, guys. So 2 plus 3i times 2 plus 3i times 2 plus 3i. Let's do these two first and see what we come up with. So 2 times 2 is 4. And then 2 times 3 is 6i, or 2 times 3i is 6i. But you're going to have 2 of those, so 12i. And then 3i times 3i is 9i squared. Again, the 9i squared turns into negative 9. So here's what I still have. I want to rewrite this in a nice logical statement here. Correct mathematical statement. So 9i squared is negative 9. So the difference between 4 and 9 is, what's that, 5? And the 9 is larger, so negative 5. So here's what I have. Negative 5 plus 12i, see? And then 2 plus 3i. And now what we're going to do is we're going to distribute those two. So hopefully all this is making sense to you guys. I hope that I'm not confusing anyone. So here we go. Negative 5 times negative 2. This time I'm just going to have to FOIL, right? We're just going to have to do FOIL old school. Negative 5 times negative 2. Oh, sorry, I said negative, but there's no negative there. Negative 5 times 2 is negative 10. And then negative 5 times 3i is, what's that, negative 15? So minus 15i. So there it is. I'm done with that. And then 12i times 2, that's going to be a 24. 24i. And then 12i times 3. 12, 24, 36. So 36I squared. Okay, hopefully everything made sense to you guys. Are we still good? I can't hear you guys, so I'm not sure if we're good or not. If we're not good, please pause it. So combine like terms, and I'm going to turn that 36I squared into a negative 36. So let's see. Negative 10 minus 36, that's going to be a negative 46. Because when they're the same sign, so you can just add them up, keep the negative. And then 15 and 24, the difference between 15 and 24 is 9. And 24 is larger, so it's going to be a positive 9. So plus 9I. And there it is. If I did everything correct, that should be the right answer. And let's find out if we did. So open parenthesis, I'm going to put 2 plus 3. And then I'm going to insert an I in there. Come on, buddy. And then get out of there and go to the third power. To the third, enter. So negative 46 plus 9I. Yeah, we did it right, guys. Let's keep going. All right, what if it's in complex form? Chavez, I'm scared. Don't be scared, guys. It's not that bad at all. So we're going to do the same thing, guys. And I know I put more space in there. I was assuming that I might need more space, but now that I'm thinking about it, we probably will not need it. So let's find out. Let's find out. So that means, well, I already have, it's already there, so I'm just going to rewrite it again. Square root of 5 over 4 minus square root of 5 over 2 with an I on it. All right, so here we go. I'm going to multiply those two first. So when I multiply square root of 5 times square root of 5, that is just going to be 5. And then 4 times 4, that is 16. So there it is. Now I'm going to go like so. So square root of 5 times square root of 5 is going to be 5. So I'm going to do this here on the side, guys, because we're going to have two of them, remember? Well, you know what? We'll just do it like this. Square root of 5 times square root of 5 is going to be 5. And then 4 times 2 is going to be 8. And then I'm going to and I'm going to have two of them because now I'm going to do that right there like so. So I'm just going to go ahead and write it this time in case it's a little more complicated than the others where I could just double it. So I'm just doing it like that. So there it is. And now I'm going to do these two right here. Negative times a negative is a positive. So plus 5 over 4 I squared. So there it is, guys. I hope I didn't make that too complicated. I hope it was simple. Now we just got to combine like terms. To combine like terms, you need the same denominator. These already have the same denominator, so we're good. No, you didn't have to do this. You could have just doubled it from the beginning, and you would have gotten your answer. But I just want to show everyone the steps here. And yes, I realize that we're going to reduce that in a little bit. So give me some time. And then that I squared is going to turn into a negative. Well, I squared is going to turn to a negative 1. So that plus is going to turn to a minus. So minus 5/4. All right. So I can't add or subtract unless I have a common denominator. So I'm going to turn the 5/4. See how I have 5/16? I need to add those two in blue. So I'm going to multiply this by 4 over 4. So when I do that, 5 times 4 is 20 over 16. So now we're ready. So 5 minus 20. The difference between 5 and 20 is 15, and the 20 is larger, so it's going to be a negative. So I'm going to have a negative 15 over 16. And then the 10/8 reduces. 2 goes into 10 5 times, and 2 goes into 8 4 times. So that's just going to be minus 5/4 I. If I didn't do anything wrong, that's what I should get when I type it into the calculator here. So let's find out. So I'm going to write, where are my little fraction thingies over here? All right, so square root of 5. So square root 5 over 4. Come on, buddy. And then square minus. And then let's put that little fraction thingy again. Square root of 5. And on the bottom, let's put a 2. And then to the right, let's put an I. So, sorry guys, it takes a while to type on a computer that's lagging a little bit because it's using up a lot of horsepower to record as well. So here we go. Push enter, and there it is, guys. Negative 15 over 16 minus 5/4 with the I. Yep, we did it right, guys. So I guess we did need all that space. I could have written smaller, I guess. All right, so here's another one, just so we can practice some more. We're going to do the same thing. So 3 over 2 plus square root of 7 over 3 with an I on it. put a square on it. Well, I guess it already has a square, so let's just expand it. 3 over 2 plus square root of 7 over 3 with an I on it. Okay, again, 3 halves times 3 halves. So that is going to be 9 over 4. 3 times 3 is 9, 2 times 2 is 4. So now I have this one here. So that's going to be, let's see, plus, well, I guess we can cancel the 3's. Well, let's not do it yet. 3 square root of 7i over 2 times 3 is 6. So notice 3 goes into 6 twice. So I'm going to erase the 3 here, and I'm going to put a 2 there. That would have been the same thing as canceling the 3 in the top and the 3 in the bottom and having that 2 there. So there it is. And you're going to have 2 of those because now I have this one here. So if you're going to have 2, well, I guess I will do it again here. Square root of 7i over 2. I'm really tempted to write a 2 here in the front of that and just cancel that 2, guys. But I don't know y'all's ability yet. So I'm going to try and show as much detail as I can. So then square root of 7 over 3 times square root of 7 over 3, that's just going to be 7 over 9i squared. All right, so let's see. When I add these 2 up right here in the middle, there's 2 of them. So we have 9/4 plus 2 of the square root of 7 over 2 with an I on the outside. You can put the I on top of the square root of 7 outside of the square root, of course, make sure. Minus 7/9. And it looks like we're going to have to do common denominator. These 2's cancel out right there. So I want to add up these 2 right here, the 9/4 and the 7/9. And it doesn't look like there's like a super fast way. We're just going to have to do just good old basic, common denominator. So I'm going to multiply the 9/4 by 9 over 9. And I'll multiply the 7/9 by 4 over 4. So 9 over 9 is the same thing as 1, and 4 over 4 is the same thing as 1, so you're not changing anything. So when you do that, let's see what we have. We have 81 over 9 times 4 is 36. And then 7 times 4, 7, 14, 28. So minus 28 over 36 plus square root of 7i. And we want to add these 2 guys up. So 81 minus 28. Let's see, 81, 71, 61, 51, 53. So it looks like 53 over 36 minus or plus square root of 7 and then I on the outside. Maybe put it in front of the square root. I hope I didn't do anything, I hope I didn't add wrong. Let's see, 81 minus 30, 81, 71, 61, 51 is 51, but 28 is 2 away from the 30, so add 2, so 53. So it looks like we did it right. Let's find out. Let's find out. So I'm going to take my little calculator, and I'm going to do, so 3 halves, so control, little division sign, 3, come on, buddy, 3, 2, and then here we go, plus, and then again. Yeah, this is exciting, guys, I know. Square root of 7, come on, buddy. Oh, look at that, lame. Maybe it's easier with a mouse. Nope, it's not easier with a mouse. Square root of 7, scroll down, and then 3, and then put the I. Where are you, I? Here we go. And then finally, we put a square on there. All right. Let's see, 53 over 36 plus square root of 7 with an I on it. There it is, guys. So we got it right. I actually kind of prefer, because sometimes the square root drags a little bit. So I actually prefer, and I think most mathematicians would probably prefer this, the I in the front of the square root of the 7. But it's not a big deal. All right, guys, I hope you guys enjoyed this. I think that's it. So give it a thumbs up if you enjoyed it. I mean, I guess you can give it a thumbs down if you want, but thumbs up. And if you loved it, subscribe. And if you saw this with your family, that's awesome. I hope that they got some good entertainment. Maybe they learned a little something, or maybe they already knew it and they just needed a refresher. And they're like, yes, I understand completely. This is so awesome. So I hope you enjoyed it, guys. And I hope you enjoy your first official assignment for the summer. All right, guys, take it easy. Talk to you guys later. Bye.